Hello, everyone. It is lovely to be here this evening on Earth and also to see what is happening in the International Space Station right now. My name's Natasha de Vere. I'm from the UK, as you can possibly tell, but I work at the Natural History Museum of Denmark in Copenhagen. And I'm an associate professor and curator of botany. And what I'm going to tell you a little bit about is some of the work that I do and the work at the museum on plants and pollinators and how we can protect them, and in particular, certain plants which are in this ball here, in this biodiversity sphere, and are now up in the International Space Station. So, first of all, in the middle of Copenhagen, we have our botanical garden, and part of my role as curator of botany is to look after the living plants within our collection. And our botanical garden first opened to the public in 1600, but it's moved a few times around locations in Copenhagen to the location it's in today. And at the heart of our botanical garden is our beautiful palm house, which opened in 1874. And if we go inside the warm and humid environment, very different from what it's like outside at the moment, we find plants from tropical and Mediterranean regions throughout the world. And those plants in the wild are often incredibly rare and threatened, so it is important that we're able to look after them within our botanical garden. To give you some examples. So this plant here is called Wollemi pine. And there's a little piece of this Wollemi pine in our biodiversity sphere here and up in the International Space Station. And this tree would have been around originally at the time of the dinosaurs. They would have been walking past and munching on little bits of this tree. And actually, it was thought to be extinct. It was thought to have become extinct 2 million years ago. And then, in 1994, something miraculous happened. Some people found some Wollemi pines. They weren't extinct after all. There was a few trees left in the Blue Mountains in Australia. The plants are quite rare. There's not very many of them left. So conservationists are working hard to protect the plants in the wild from pests and diseases and fire. But what they also did was they propagated the plant and they gave it to botanical gardens throughout the world so that we can conserve it. And our Wollemi pine here is quite a youngster. It was planted in 2013, but in the wild, these plants can live for 500 or 1,000 years or more. So the world that they experience is very, very different from our own. But we have some plants in our botanical garden which are a good bit older. This is a cycad. It would also have been growing at the time of the dinosaurs. And this particular type of cycad is called a queen sago. Although this individual is actually a male. And we also have 2 females of this tree in the botanical garden as well. And there's a little part of this cycad in the biodiversity sphere as well and up in space right now. And we know a little bit more about this particular individual because we have the original seed packet from when the plant first came to our botanical garden. And it was actually planted in 1824. So that was when it was first planted as a baby cycad, and then it was moved into our palm house when the palm house opened to the public in 1874. So this is a pretty old specimen, and this year is its 200th birthday. So it's a pretty good present to end up being in space when you're 200 years old. So as well as the living plants in the botanical garden, part of our role as a museum and part of my job as a curator is also to look after preserved pressed plants, and we call them herbarium specimens. And under my care, I have 2 million of these specimens of pressed plants, and they go back from before 1600 right up to the present day. And these plants are a record of past worlds and past environments. They can tell us something about how conditions have changed over time, and also we can use them to predict what might happen in the future. We can even go to these specimens, which are hundreds of years old, and take a sample of DNA and compare it to today. If we can find out how these plants have adapted over the last hundreds of years, we can help to predict what might happen as climate changes in the future, and most importantly, what we can do about it. So one of the areas that I work is on the plants and the pollinators of Greenland. And within our herbarium collection, we have 190,000 herbarium specimens from Greenland. Our oldest specimens are from a book herbarium of preserved plants from 1739. And it's important to be able to look at what's happening in the Arctic and, for example, in Greenland, because the environment there is changing very, very rapidly. Greenland is still a land of glaciers and ice, but it is warming up quickly. If we can find out how things have changed in the past, hopefully we can use information to see how we can help things as they change in the future. So part of the work that we're doing is looking at the plants of Greenland in the herbarium and comparing them to the present day. Do they flower earlier? Do they set seed at a different time? Do they have the pollinators that they need in order to survive? And over the coming years, we will be answering these questions using the herbarium and fieldwork in Greenland. But we went back last summer and we went to see, could we re-find our plants from 1739 in the herbarium? How quickly do things change? And so we went to a town called Kisiengarit in Greenland last summer, and this is what it looks like here. And we looked to see, could we find these different specimens of plant from 1739? And actually we could. Nearly all of the species that were collected by a missionary in 1739 were still present today. So although things change, some things also stay the same. And the plants were found around the outside of houses and in the hills surrounding the town, where the original collector of the plants probably walked hundreds of years ago. We're also interested in looking at what pollinators are doing. And in our space ball, we have a bee as an example of a pollinator. Because we want to know, how do plants and pollinators interact, and how might that change in the future? So we collected pollinators from different locations throughout Greenland last summer in order to be able to answer that question. But how do we answer that question? How do we know what plants pollinators use? Because they're flying around the place far too quickly for us to be able to tell. We could use observation, but it's difficult to watch a plant to see what pollinators visit. It's difficult to follow a pollinator as it flies and travels through the landscape. But what we can do is we can look at the pollen on the body of a pollinator, and we can use that as a record of all of the different plants that the pollinator has visited. And we can identify that pollen using DNA identification. And so that's the work that we do. First of all, we take a pollinator, we take the sample of pollen from its body, and we extract the DNA from that. And then we amplify short sections of DNA called DNA barcodes, and we amplify them up, and then we compare them to a big reference of all of the plants of Greenland in order to see all of the different plants that pollinators are visiting. And we're analysing our results from last summer at the moment. But I want to give you an example of how we can use that for something else. So one of the other areas of work that we do at the museum is we want to know what plants are important for pollinators in our gardens. We know that a loss of flower-rich habitat for foraging is a big factor in the decline of pollinators in the wild and ill health in honeybees. If we can find out what plants are most important, then we can actually provide them in our gardens and green spaces, and we can do something to help. So one of the projects that we looked at within a garden. In this situation, it was the Botanic Garden in Wales. And we looked at what different plants were used by different pollinators. We looked at hoverflies and bees, and we looked at different types of bees: bumblebees, honeybees, and solitary bees. And over 2 years, we collected pollinators from transects that we walked within the botanical garden, and we collect them from March to September over these 2 years. We then do our pollen DNA metabarcoding to find out what plants the pollinators have used. And we can use this to reveal hidden interactions. This network on the left-hand side shows you all of the pollinators on the left that we found within our botanic garden. And then on the right are all of the plants that we found on the bodies of the pollinators. The bars in between show you the amount of DNA for each one of those plants. So it gives you an idea of how important they are. And what we find is that there are lots of plants used and lots of different pollinators, but there are certain plants that come up as really important time and time again. So, for example, plants in the family Apiaceae, they're called umbellifers, and they have these big, flat flower heads that it's easy for a pollinator to land on. Also, thistles and buttercups and brambles and dandelions are really important for pollinators. We can also have a look within all of the different groups. We can say, okay, are there certain plants that are more important for certain different bees or for hoverflies? And this just graph here on the middle compares, on the left-hand side, hoverflies, and then next to that it's bees. And we can see that although there's plants that are similar, they also use some different plants as well. So in green, these are the plants that the hoverflies like best. And they actually like these plants in the umbellifera, the Apiaceae, these ones which are easy to land on and to collect pollen and nectar. Whereas the bees really like thistles, where they have a slightly longer flower they can stick their tongue into. If we look at the individual types of bees, some of the honeybees and bumblebees are quite similar, but the solitary bees, and there's lots of hundreds of different species in Denmark and the UK, they're much more variable in the plants that they use. We can also look at, do pollinators in our gardens prefer native or garden plants? And actually, we see that in the spring and the summer, they much prefer native wild flowers. So that's what's shown in green on this chart. But when we get to autumn, they start to use garden plants more towards the end of the season. So using this information, we can start to make recommendations of what people can do in their own gardens or green spaces or even balconies in order to help pollinating insects. So bees and hoverflies use different plants. We need to make sure that we provide all of them within their environment. Different plants are used throughout the year, particularly the beginning and the end of the season. It's important to provide enough food. And bees and hoverflies use more native wild flowers compared to garden plants. So that means we should make space for these in our gardens. Sometimes even the self-sown wild plants that sometimes we call weeds, they're really important for pollinators. So sometimes we can do a lot for biodiversity by actually doing nothing at all. So stop weeding and stop mowing the lawn and give a bit more space for wildlife. But if you do like to plant some flowers, plants that extend the growing season at the end of the season, they are good for pollinators when they're still flying, when it's a little bit warmer. So I wanted to thank you for the opportunity to tell you a little bit about the work that I do, and whether it's curating the plants in the botanical garden or in the herbarium or field work in the Arctic or closer to home in Denmark. I feel incredibly privileged to be able to find out more about the biodiversity that we share our planet with. And I believe that together we can all create positive change for people and planet. Thank you.